My slides are up at dexy.it/ado, which might be helpful since they don't seem to be here, but we're getting there. All right, just a little about me to explain why I'm here and why I'm talking about what I'm talking about. So I'm a software developer. I used to be an economist, and I got interested in software development while I was doing my economics PhD, and I sort of never went back. I also got interested in document automation while I was working on my thesis, and I sort of realized as I was working on my thesis that there were a lot of similarities between software documentation and the sort of automation I was trying to do to make my thesis be correct and be efficient to produce. So I thought a lot about that at the time. I thought a lot about that as I became a developer after I graduated, and eventually I learned Python and I was able to write my dream documentation tool, which is what I'm here talking about today. There's my Twitter. So my dream tool is named Dexy, and a little bit about it to start with. It supports any programming language, it supports any kind of document, and it works by automating your entire project. You can find more at the website, and you can also follow the project on Twitter. And there's the word ado was in my title, and that refers to a little experimental fun to-do app that works on the command line. And it might be interesting in its own right, or it might just be useful to be an example for what I'm talking about today about Dexy and documentation. So we've all had 2 really, really wonderful days here, and we've been talking about documentation, which I think of as the space between code and prose, or the interaction between code and prose. And we've had in the last couple of years some really amazing development in our tools to create both of these things. So we've had there's some great new version control tools that are so much nicer than the old ones. We have new text editors coming out, and we also have great old text editors that have been around for years. We have distribution networks like GitHub to help us share code more efficiently. We have new ways of sharing prose content, like content management systems and wikis and all sorts of really, really fun, exciting things. But what about this integration between code and prose and actually writing documentation? Well, we've had some good tool development there also. And when we're trying to integrate things, usually there's automated ways to do that or manual ways to do that. And the automated ways for generating documentation fall into one of 2 categories generally. And we've heard a lot about both of these over the course of this conference. So the first one usually follows the methodology of place the code in the prose, and this is literate programming, which we heard some nice presentations about this morning. And the other option is place the prose in the code, and this is when you write comments in your source code, and that becomes automated API documentation, and pretty much every language out there has a system for doing this. So these are both really helpful approaches in some circumstances. There's also some problems with these approaches. They're very, very inflexible, and they also tend to make it quite hard to reuse our code. So if you're going to write a literate document, that can be really, really beneficial, but then if you want to reuse that code in another document, let's say you want to have an example that's both in your README and in your Hello World, and then in maybe some slides you want to make, and then maybe in a blog post, it gets tricky to reuse that in all those different places. Similarly, API docs are really, really useful, but they can be hard to edit. It can be hard to edit the templates, and it can be hard if you just want to reuse a little bit of that information in a different place. It's not always set up to be easy to do that. So we use these automated tools. We especially use API documentation, but as pretty much everyone here knows, API reference documentation is not enough. So we also need to create other forms of documentation, tutorials, user guides, blog posts, all that other stuff. And when it comes to the other stuff, it can be tricky to do something other than manually integrating the code and the prose together. So we do things like copy and paste code into a WordPress editor, or copy and paste into a Word document, or heaven forbid, try to actually compose code in one of these things, which when you do Python with significant white spaces, it's especially fun to use word processing tools for that. So there is a third approach. I mentioned code in prose and prose in code, and there's another approach, which I want to talk about, which is code is code and prose is prose. So this is another approach to automating software documentation and other things too. And the idea here is that, all right, you're going to have code, it lives in code files. You're going to have prose, it lives in prose files. And then you're going to have tools that help you integrate those 2 together. So the benefits here are you're always editing things in tools that are appropriate to edit that thing. So you're not going to try to edit or copy-paste code into something that was designed to format words in a human language. If you keep code in your code files, it's always going to be executable. You can always run it. You can use it in a library. You can run it to test it, and it's pretty easy to update and see what's going on. And also, we have not ruled out any of our previous options for automation. So you can still do literate programming, and you can still do automated API generation. You can still mimic those two things, or you can still just support those by having those be one of your inputs. So I'm going to talk about the tool that lets us do that in just a minute, but there's one more thing I want to add to this. So this was my original diagram. So we have code, and we have prose, or sort of English words. We have documentation as the space between them. But let's add one more thing. Let's add data, because I'm guessing everybody in this room works with data of some sort, and it goes really well with the rest of these things. And data can mean data you get from an external API. So maybe you query an API and you get some geographical data. Maybe you get data about just about anything today. This could be data that comes from doing code performance analysis. This could be data that comes from your website traffic, from your Google Analytics, or from whatever else you're using to monitor any kind of traffic. This could be your metrics from your support help desk, and it's been nice to see a few people talk about this. You get feedback on how good your documentation is in large part by how efficient your support is, so that's another form of data. We've all heard all the buzz about big data, and there's just a lot of really cool stuff going on when you actually start to analyze data. So I think it's important to add this to the picture. So when we add it to the picture, we get some really interesting new things. We have documentation like we had before, and we also get reporting, which is what happens when you integrate data with words, and then we also have analysis, which is what happens when you apply code to data. And applying code to data to do numerical analysis of some sort is pretty much why computers, were invented. And it's really, really amazing what you can do with that when you take some data and you're going to distill it down using the power of automation to get actually relevant results for yourself. All right, so we have a lot of really interesting stuff here. Another way to think about it is we have things that cost us money and are the inputs to what we do. Code costs money. You have to pay developers, and they've had to spend a lot of time to learn how to write code. Similarly, prose costs money. You've got to hire writers of some sort, and they've spent a lot of time learning how to write. Data costs money. You have to either purchase data or collect it yourself. If you collect it yourself, you have to have people who know how to do that, and then you have to store the data in a database, keep it clean, keep it sanitized, know what the data is, and be able to get it when you need it. But we turn these things into very valuable outputs that are really where, people pick different niches in this, and that's where they really add value. So we're producing things like documentation, which lets us add value to our code or provide support or just get people to use really awesome software so their lives can be better and their work can be more efficient and effective. Reporting is what pretty much anyone who works in an office does all day to some degree. You're going to, work in spreadsheets, you're going to prepare information, you're going to send it to people who need to know information. And analysis. All right, so here we have code as code, we have prose as prose, now we have data is data, so we've got data living in data files, we have code, which is going to be analyzing that data or just doing its own thing, and we have words that are going to put all of this into context and have it make a lot of sense. And the tool that we can use to help integrate all of this is my dream tool from my thesis days, which is called Dexy. And so Dexy is a tool for automating the integration of code, prose, and data. And that means it's also a tool for automating analysis, reporting, and documentation. And you really do get the best of both worlds here. You get just as much flexibility as you have with manual copy and paste, write whatever you want, but you also get the benefits of automation, and you get the benefits of reproducibility and maintainability that you get when you take an automated approach. So what are some things Dexy can do? It can run code, it can take code and insert it into documents. We can get the output from running code, insert that into a document. We can convert documents to different formats. We can run scripts to do data analysis. We can insert results and graphs into documents. We can just do general automation tasks. Write a script that does something for you, something useful, and just this goes in your Dexy project and Dexy runs it for you. And we can also do things like interact with remote APIs. So we can have filters or scripts that go and get data for us to be the first step in our automation. Or we can have scripts that take the output we generate and push it to a remote API. So you can write your blog post locally using Dexy, and then Dexy's filters can publish that to the API for you. So we can pretty much do anything we need to do in this system. So here's my sloth, which is the mechanized automated sloth. And everything is set up, and you just have to pull the lever and say go, and then everything comes out for you. And we're going to be inspired by this law of slow pace and have a really calm life, because we've automated everything in advance, and now all we have to do is say go. All right, so I'm going to do an example for you and go through some documentation that's been generated by DEXI of a couple different kinds. I mentioned the software called Ado, and I decided a while ago that I wanted to try to write some, a to-do app, because there just aren't enough of them out there, are there? But I wanted one that was going to be not web-based, because I just felt I wanted my information local, and also, just to have it, not have anyone else have access to it. I wanted a really simple interface. I just wanted a command line tool, because that's what works well for me. And I realized I'm trying to make a very simple tool, and one of the ways I could make that very simple is not worry about reporting in this tool, because I already have an awesome documentation and reporting tool that I wrote, so I should use that. So I decided what I would do is just make the data in the system available to DEXI, let DEXI run all the reporting. And then that just meant my to-do app could be really, really simple, and then I could do everything else outside of it. So basically, my software is just a really simple wrapper around a SQLite database and a command line tool for inserting data. And then anything I want to do on the reporting side or the presentation side, I do using DEXI externally. There we go now, the fun part. So this is this is the slide I have up at, oops, wrong screen. Let's see, it's a little small. Okay, if I can find my mouse. All right, so this is the website, very simple at this point, and I'm just going to go into the Ado guide. And we're looking here at some documentation that's been generated by DEXI. These are originally restructured text documents, and they've been compiled to both HTML and PDF by DEXI, all at the same time. And I could add a bunch more formats to that if I wanted to. We have the option to view them as a single HTML page, and we have the option to download the entire thing as a PDF. And we're going to go through each of these individually and look at them in the HTML format. The other formats are already there for us. We didn't have to do very much to get them once we set it up. So I'm talking here, this is a little installation guide, and I just will tell you pip install Ado will not work quite yet, because I just need to get a new version out, but it'll work a few minutes after this talk. And what I'm doing here, I'm writing this explanation of what I'm doing, but what I'm doing behind the scenes is referencing a bash script that has all these commands typed into it. So I can run this bash script. Hopefully I'll run it in something like a virtual machine, or what I do a lot is I fire up an EC2 instance that I know is just a blank machine, and I write a script that installs the kitchen sink on that machine, and then I do my documentation on that remote machine. And that way I have my install script, and I can turn that into installation documentation for whatever I'm doing. Which is really nice, because that way I know I've captured all the dependencies and I know I've tested my script. So here's some install instructions, and then I can tell people, all right, after you've installed this, you should be able to run this command, and I'm showing you the input and output from me actually running this command in my script. And here's the source of this page, and what we're doing is we're referencing an install.sh script. It's been run through some filters that I'll talk about later, and I'm pulling in just the section that I want. So the nice thing here is you can write a really long script, or as much as you need to contain, and then you can pull it in section by section in your document so you can explain what you want. And obviously it's very easy to just include this code chunk in any number of other documents that you have that you also want to reference this same chunk. And we can go back to the next section. So the next section I have is a getting started, which is actually going to go like a tutorial step by step through how you actually use this system. And the specifics don't matter too much. You run a setup command, you create a database. Here we're doing a manual dump of the database to verify that everything's in there that we want. And now I go through, okay, we can add notes, and here's how to add a note. And again, this is live code that actually ran. And we can do tasks and all the other stuff you would expect in a to-do app. So I want to just keep going through here. The next thing I have is a reference to the command line interface. So I've given you a getting started guide to kind of introduce you to the concepts and help you get started and give you some basic commands to type. And now it's like, all right, now you can go and look at the command line documentation and actually figure out all the other things that you can do now that you're sort of oriented with the software. And here I have a much more automated approach. The previous section was much more, I'm going to write a guide, help you get through step by step. And now I'm doing something closer to automated API documentation, but I still have total control over what I'm doing. So what we have here are all the different commands. And I'm going to pick one at the end. And here is, this one has very little help. I'll go up one. All right, so we have a command called adoValues. And this command, as we learned from the doc string, it's going to get, the do has a thing called a metric, which is if you want to keep personal metric information about yourself, you define a category you'd like to keep track of, and then you store values for that category at a regular interval. So this is how you get that data out. And this is set up so you can actually pipe it to like a Spark line, or you can do some other reporting on it. So here's the help. And the way we built this page of documentation is we're going to just loop over a list of all the available commands, and we're going to pull in the help text for those commands. So this page is completely automated, and if the commands change, the next time you run DEXI, everything is going to be updated with the most up-to-date information. Just going to get through two more, and then we'll go actually see the source code and actually run DEXI. So here is... here's a guide to actually running the reports with DEXI. So this is in the ado help. The ado is saying, okay, now if you want to run reports, you need to make sure that you have DEXI. And here's how to use DEXI's templating system to generate a template. And what we're actually going to do is start a little static web server. And then we're going to take a screenshot, an automated screenshot of what you should see when you load this page into your web browser. So this is a screenshot of, this is the actual live HTML. But this is a screenshot that was automatically taken by DEXI when it ran. So this is something you can do with web applications as well. Is the way this works in this particular iteration is we're going to start a web server, and you can see all the bash commands I'm doing here, and I'm going to save the PID for later so we can shut it down. And then we're going to use Casper.js, which is a really nice tool for, it's basically a wrapper around Phantom.js, and it lets you start a headless JavaScript web browser so you can open web pages, you can interact with them, you can type data into the web page, and it has a really, really fantastic method, which I forget the exact name of it, but the gist of it is a render element, so you can basically take a screenshot of just a named element on the page, which is really, really nice. So what we're doing here is we're starting a server, and we're going to interact with that server, and we're going to load pages, and then we're going to capture screenshots from that page to PNG and PDF format, and then we're going to integrate those with our documentation. And so we can see the PNG here. And I'm just going to go into the actual one. So this is the live HTML, and what we have here is a nice D3 interactive little widget which lets us basically click and drill down into the different hierarchies of these to-do datas. So finally, one more thing in the documentation guide. What we've seen up to now is we've seen some tutorial example scripts that went through and basically got pulled in sections of code that show you how to do things, and it showed you the input and output from running that code. Then we saw how we automated some API documentation by iterating over a list of commands we had and pulling in the help for each command. So now this section, which just has a few examples on it, is just talking about the internals of how this was implemented. So this is more developer-facing documentation or internal documentation. And what we're doing here is we're going to actually pull in examples of the ado source code. And we're going to do this just by referencing the name of these methods, and then we get the source code in our documentation. So the nice thing here is you've got your source code, you have just written your normal Python package, and then what you can do is pull out a chunk of the documentation and put it wherever you want it. So here's where we're seeing we have API-style documentation. We have doc strings here. So the doc string here is, list all the projects, tells you what this command does. And we have the source code living in source code files. And now we have a lot of other options for what we do with that. So we can generate automated API documentation. We can also say, all right, I just want to talk about this one particular method and this particular point in my documentation, so I'm going to go ahead and pull that in. And then again, we can pull in, here's another method. This is the setup database method from a different class. All right, so I'm going to go and actually run. Cool. Okay. So this is an example of a DEXI project. So the way I personally work when I'm working with DEXI is I use Screen, which lets me have multiple tabs open, or multiple buffers, and I can run commands and do all sorts of different things in the different windows. So basically, that is how you run DEXI. You type the word DEXI. It's just as many letters as make, but better. And you tell DEXI what you want to do by giving it a, oops, sorry, my mouse is. You tell DEXI what you want it to do. There we go, sticky windows. By writing a configuration file, which is in YAML format, which looks like this. And what you're doing, so hard to find the font. Okay, so what you're doing is you're specifying a hierarchy of the documents that you have and what are the inputs and dependencies of those documents. And DEXI is going to go through and parse this. It's going to figure out wildcards. It's going to work this all out, and it's going to figure out what order it needs to run all your documents in to make sure that the dependencies are there when you're time to run your actual document. So we're saying that we want to copy all the things that are JavaScript, PNG, and CSS files. Let's just copy those over to our finished output. It's saying that if you see a document named index.html, we want to run that through a filter called adojinja, and we want to have this other thing called docs as an input to that. And this means that anything that's under docs is going to be available to this HTML document when it gets rendered. We also have we have a Python script which is called export_data_json.py, and we're going to run that through a filter named py, and we're going to do something called add new files as true. And then we have some other documentation up here. We have a Markdown documentation, and we have a TEX, a LaTeX file documentation. So we have several different document formats here, and we also have a Python script that we're just going to execute. And this has all been specified in this one file. And once we've specified, all we have to do is just type the word DEXI on the command line, and this is all going to get run. So what we've done here is we're referring to the SQLite database that has all this to-do information, and we're just generating a bunch of reports based on it. And this is the index.html that gets generated. So we had an export data JSON Python file, and that is going to generate this JSON data. And that JSON data is going to be read by some JavaScript that gets loaded into this page, and it's going to generate this little interactive tree hierarchy here that we can go into. And then this is an example of a report, but as I mentioned, reporting and documentation are very much related to each other. And so what we're going to do is we're going to scroll down. We're going to look at our lists of tasks and portfolios. So here's all of our to-do information. We can plan our to-dos, do all that. And oh, look, we have docs right in our reporting because we can reuse this stuff as much as we want. It's very cheap to make static docs. And so what we can do is in the middle of our report is we have the documentation on how to do additional things with this system. And if we go look at here's our HTML document. And so our JavaScript is reading this file, ado.json. Ado.json does not exist when we start, it gets generated in the course of the DEXI run, and it's there by the time this page is rendered. And we have our list of projects and lists of tasks that all get generated for us automatically here. And then we have this docs div, which is pulling in a separate documentation document, and it's just inserting that in our report. And this is basically a list of all the documents that are generated in our system. And you can see that where it says consolidated, that means this doc was actually run from the cache that DEXI keeps. So another thing DEXI does, because it knows all the dependencies between your documents, it is only going to run what it's necessary to run based on what has changed. So if I touch the export data JSON.py script and I run DEXI again, And now I'm going to cat that same file, and you can see that this script was run. Everything else still ran from the cache. So the nice thing is that DEXI is very, very fast when you don't have much to rebuild. And it's going to basically only build things that depend on something that you can see that this bundle depends on this. So it also got reevaluated because one of its inputs has changed. Okay, so what we've seen here is a lot of different types of documentation. We've seen a lot of different, we've seen Bash and Python programming languages. I also do a lot of work with R and with lots of other languages. So for my own stuff, I tend to have a mixture of Python and R and Bash because I tend to write install docs as much as I can for things. And we've seen, we have documentation that's written in Markdown, in pure HTML. Let me show you. And the LaTeX is basically, we can insert tags here and make use of this information to do reporting in LaTeX also. So we can mix and match. We can mix and match the languages we use. We can mix and match the data formats we use, and we have access to a whole range of filters for doing different things. So we can pretty much support any programming language. We can execute the code in a dozen different programming languages in a single project. And then we can make use of the same information in a lot of different ways and do quite a lot with it. So there's definitely a lot more examples on the website, and there's definitely a lot more that DEXI can do. One way to think of it is a document-oriented make tool. It has a lot of really, really fun features, and it either works with or replaces a lot of your favorite tools, which depending on your preference. So there's a lot of different combinations that are possible there. So it's a very, very fun thing to try out. And let's see. Yeah, very fun thing to try out. There's a lot of very cool integrations you can do with it and a lot of different things to try. So that's it, and I'll take questions. Do you want to?
Does it run on Windows?
It should. There's a few features in it that do not, but it is written pretty much in Python, and so as much as Python runs on Windows, there's a lot of the filters currently depend on a Python library called pexpect, which is not Windows compatible, so you have to sort of not use those. And I haven't tested it in the last couple weeks on Windows, but I will be doing that. So in theory, yes. And if it doesn't, let me know, and I'll fix it.
Are you aware of any, so it looks like you can reference things that are on the file system. Is there plugin architecture such that you can reference things in a Git repository, like in a specific version?
Yeah, so I don't, you certainly, there's a couple ways you can do anything like that. One is to have it sort of built into DEXI, and the other is to just make a script that does that. So if you actually had a script that called git clone, then you could use those files. Actually, that's a feature I had it previously in DEXI where instead of referencing a local file, you could reference a remote file. So that's certainly feasible, and if you, please get in touch if you have a particular use case for that, but that's definitely feasible.
Any more questions? Am I missing anybody? No. Oh, yes, Eric.
Can you show like a basic extension and maybe what that API looks like?
Sure. Let me see if I have.
That's a lot of extensions.
Yeah, there's a list of them on the website. And so these are some, sorry, my mouse keeps getting caught on the wrong window. So what we can do with filters, all right, so here's a nice filter in just a few lines of code, the head filter, and that's basically doing it's taking the first 10 lines of the input. So all we're doing here is we're defining a process text method, and that just takes text, changes it in some way, and returns the output. So that's sort of the simplest way to implement a filter, is just write a class in Python and do some simple things to it. And obviously, if you've got a Python library, you can do that. But there's also You can also just, if it follows a pattern very similar to an existing filter, you can actually configure new filters just with YAML. So what I've done for most of the programming languages that I support is they follow sort of pretty standard, you're going to have an interpreter or compiler. It's going to follow hopefully pretty standard, protocols, either going to launch a REPL or you're going to compile or interpret code. And so for all these, there's a giant YAML file, and basically I just have just some constant set for each one. So let me just find the herb. All right, so here's a JRuby filter, and here's JRuby where you just get the output of the JRuby command filter. So these are obviously very, very easy to write. If there's a language that I'm not supporting that you like, you can email me or you can do this yourself and send a pull request or a patch. And this is just a case of setting constants. Otherwise, there's a little bit of Python code. And what you could even do if you had some more complex things and you didn't want to use Python, you could write a filter in your native language, and we could use the sub process to actually go ahead and call that.
How about documenting like a REST API?
So that's a really good, that's a really fun example. And there's really good tools out there, I think, now for sort of automating some of that. But where they tend to have trouble is in the getting started part and in the actual making interactive docs. So one of the things I really like about DEXY is that it for the most part, it keeps you honest, because if you are actually so you can show code you haven't executed, but if you choose to actually execute the code and show that, you have to show real code. And one of the problems with APIs and REST APIs is that there tends to be sort of forgetting things like, oh, let's show how to do authentication and let's show how to do the actual real things. So I had a conversation at lunch today with, anytime I go look at REST API docs, they don't show me how to authenticate, very rarely. So where do I put my key? What you can do with DEXY is, yes, you can write a bash script that interacts using curl with that API, and that can be the basis of your documentation. Or you can use something like Python requests is a great library, which looks really, really nice and lets you show these really simply formatted examples. So one of the examples I have where I tried to do this, the only way to get credentials was to log in. I had to log in to the actual website and get my API credentials, and then I could do bash. So what I had to do in that case was write Casper.js script to actually go log in. Then I took a copy of the cookies, and then I used those cookies to do subsequent calls via curl. So you certainly can do that, and the nice thing about doing it with DEXY and doing it through, by calling curl and actually showing the input and the output is that it really forces you to do all the things your users have to do. And what I like to do for things like that, where you have security credentials, is I put them in an environment variable, and then I use those environment variables in my script. So that way you're actually logged in, but no one can see what your actual credentials are. So, yeah, and certainly if you have anything you want to try to document with DEXY, I'd really like to help you do that, so please do get in touch.
Oh, one more question. Here you go.
I have a question about the story at the beginning of your presentation. So I just want to make sure I understand. So the nexus of this for you was that you wanted the To-Do app as part of your thesis work, or were you actually doing...
The To-Do app is a really recent thing, and it's sort of just a toy. So my thesis research was, I was doing simulations, and so I had some Java code that was generating simulation data. And I realized very quickly that manually analyzing the results of simulation data is a very bad idea, because as soon as you rerun your simulation, you get all new data. So you're in this thing where you want to analyze the data, but as soon as you do that, you realize, oh, I've got this great new thing. I want to explore this in my simulation, but then that's going to destroy all your data because you're going to get new data. And I played around at the time. I was sort of just getting into programming at the time, and I sort of did the best I could. I used SWeave and a bunch of bash scripts to try to cobble together my thesis out of, because I had to run my code, I had to keep track of the data that was generated, and I had to analyze the data and put this all together into a document. So I used SWeave, I used LaTeX, and I used a bunch of bash scripts. And a couple years ago, when I was just thinking about getting back into writing something that would be my dream tool, I got contacted by a company who wanted to publish my thesis. And I had not saved my data files because they were so big, and because, oh, I wrote a reproducible thesis, I can reproduce this. Well, guess what? I couldn't. I could not reproduce my own thesis. I had the PDF of it, but I did not have the actual generated LaTeX. I had all the sources, but I got about a week into trying to replicate the actual data files I had used, and I ended up just giving up on it. And that really did strengthen my resolve because I had been very conscientious to, like I did not delete my source code, and I kept it in version control repositories. And I was one of the problems that scientific researchers face is that they don't always get formal training in programming, but a lot of them have to do programming. And so they tend to, like we heard earlier, like I didn't know what code comments were, and that's really true for a lot of people. They, and I was really lucky that I had some contact with web development community, so I was aware of things like version control. I was aware of things like unit testing and things like that. But even though I had that advantage, I still did not succeed in making a reproducible paper. So that's why that really sort of made me aware of the challenges. And I think by integrating the data aspect to it, it's a much more robust tool that lets you do quite a lot of very, very cool things with it.
That is a good story.
Thank you.
Do we have any more questions? Nope. Okay, great.
Okay.
Thanks a lot.
Thank you.